This storefront is plastered with sale signs. A dominant company slashes its prices to aggressively scare away potential competitors before they ever enter the market. We can model this behavior using a specific game theory scenario. Firma 1 is a monopoly with production costs that are either high, labeled CH, or low, labeled CL. The potential entrant, Firma 2, does not know the true cost, viewing the choice as a 50-50 probability. Under perfect information, the entrant's choice is clear. They only enter the market if Firma 1 has high costs, resulting in a payoff of 40. If they know Firma 1 has low costs, they stay out to avoid losing 50. Firma 1 responds to these choices strategically. Knowing high costs invite entry, they set a high price to secure a payoff of 100. If their costs are low, they set a low price, keep the competitor out, and secure 200. In this baseline world of perfect information, everyone plays to their natural type. Entry happens exactly when it is financially efficient. When Firma 1 sets a price that reveals nothing about its costs, Firma 2 is forced to calculate an expected value. Using their 50-50 belief, they weight the potential gain of 40 against the potential loss of 50. That calculation results in -5. Because the expected value is less than 0, the rational entrant avoids the risk and stays out. This creates a dilemma for a high-cost incumbent. They could set a high price, revealing their type and inviting entry for a payoff of 100. Or they could mimic the low-cost firm's price. If the high-cost firm mimics the low-cost price, PL, the entrant remains uninformed and stays out. This protects the monopoly, yielding a payoff of 110. Since 110 is greater than the 100 they would get by acting naturally, faking low costs becomes the superior strategy. This is the mechanism of limit pricing. Incomplete information forces companies to sacrifice short-term profit margins to manipulate the beliefs of their rivals and protect their market position. We can apply this same logic to continuous quantity competition. In this scenario, market demand is a function of total quantity, A minus Q. Firma 2 has a known cost, C, while Firma 1 still has a 50% chance of being a high or low-cost producer. Pause the video here. Try to write down Firma 2's expected profit function using the expected value logic, keeping in mind that they are blind to Firma 1's exact production quantity. Firma 2's expected profit equation weights the two possible realities equally, one where the incumbent produces a high-cost quantity, Q1H, and one where it produces a low-cost quantity, Q1L. While Firma 2 has a single expected profit function because they are operating in the dark, Firma 1 has two separate functions. They know exact which cost type they are and optimize to that specific reality. Asymmetric information breaks the symmetry of the math. The blind player must optimize for all possible scenarios, while the informed player optimizes only for the reality they can see. Take the derivatives of all three profit equations to generate the three reaction functions. Then substitute both of Firma 1's specific reaction functions into Firma 2's expected reaction function. Solving this substituted equation provides the final algebraic equilibrium quantities for the Bayesian Cournot duopoly. We can summarize incomplete information games with two rules. First, uninformed players always maximize their expected value. Second, informed players evaluate if mimicking another type yields a higher payoff than acting naturally. Information, or the strategic hiding of it, functions as a weapon in market competition, alongside cost and demand, changing the calculated risks rational businesses take.